Welcome to our first class in digital photography. This first class is going to cover history and digital camera basics for those who'd like to understand a little bit more about their camera. Photography is an interesting word in itself because it's derived from two Greek words meaning photos, which is light, and graphein meaning to draw. So photography, in other words, is really just the art of recording light and in essence drawing with light. More or less, it's very much like the eye, and the eye is a remarkable thing. It accommodates all kinds of changing lighting conditions and focuses the light rays, coming from various distances, and it all does that through the pupil, into the back of the retina. So it's very interesting when we study the eye. It is very much in the way a camera captures the light coming into the dark box, so to speak, and records that on the film. Well, a curious thing happened many, many years ago in ancient times. The Greek and the Chinese philosophers discovered this curious optical effect, and it worked something like this. They discovered that when they were in a completely dark room and there was a tiny hole created on one side of the wall, through the hole, the light is focused, and the outside scene was projected, yet upside down, on the opposite wall. And that curious effect came to be known as camera obscura, which is a Latin word for dark room. So this is where the first concept of what a camera could work like was actually realized. It was 2,200 years later that this gentleman, Isaac Newton and Christian Huygens, perfected the understanding of optics and the process of making high quality glass lenses. And that was a key component, of course, to dispersing the right light properly. And yet it was 200 years later, in the 19th century, that finally the important piece that was missing was developed, and that was film, some way to actually capture that light as it came through into the box. But the concept is very, very much the same all the way through. It's a glass lens, a dark box, and film to record it. Well, here's actually an example of a first photograph. This is considered to be the first photograph ever taken, and it took over 8 hours to expose in 1827. And you can make it out, can't you, with a sort of a tower on the one side there, the roof line in the middle, and this is the first photo ever taken. Well, if you want to experiment nowadays, you could actually make a camera. It's kind of a fun thing to do. Basically what you need some kind of a dark box, a cardboard box, and you could make this pinhole camera, which basically consists of, as you can see there, a piece of aluminum foil that has a pinprick in it with a pinhole and a little black paper that slides up and down, allowing the light to go in and then shut it off. And then if you can still find 126 film cartridge, this would actually record the film on the back end. Now, if you took a picture, you'd probably notice something like this happening, a curious effect where the face of this individual here is actually burned out. And the reason being is, of course, you do have no lens, so there's no way to disperse the light properly over the film. And so what you've got is a hot spot in the middle. So when we look at the camera basics, what you need is an optical element, the lens, to be able to take the light in, disperse it properly. You've got the film on the back end, the chemical element, and then you've got the mechanical element itself, which is the body of the camera. So new digital cameras today are pretty easy to use. They're just like a point and shoot, even if you have a digital SLR. But it's comforting to know that even with all the latest digital cameras and all the computer electronics that are involved in the camera, they still work very much the same way, where light passes through the lens into the camera, exposes the film, and guess what? The end result is still a photograph. So what has changed? Well, the most recent revolution in photography is the invention of digital film, and we've had that now for some time. So replacing old-fashioned plastic film, they have now an electronic sensor called a CCD, a charge couple device. And it's a way that the light rays can be captured now onto this computer chip. So putting it all together, there's several elements that you have to understand so you can be able to control the light and get those fantastic photos. And first one is shutter speed, aperture, the film speed, and then using light meters. So we'll look at two of these. Shutter speed is probably one of the most basic controls of the camera. And you can see with the picture on the right hand side there, you've got the leaf shutters opening and closing to allow less or more light to come through. And so the shutter speed controls the amount of time that your film or digital sensor will be exposed to light. So that's critical, of course, to capturing the light. And secondly, you've got the aperture. And the aperture, you can see with the picture at the bottom there, is really, it's a set of, again, like leaves that open and close very, very quick, allowing that light to come through. And once again, expose the back of the film plane. So it opens wide, like your eye opens wide, when the light is dim, and when there's a lot of light, in the room, then your pupil, will dilate. So this is very much what an aperture does as well. So what are pixels? Well, pixels are probably understood a little bit better if you actually enlarge a small portion of a photograph, like this ear of the deer, and you can see it's really comprised of millions of tiny little squares, and those are called pixel elements. And when you're looking at buying a camera, for an example, manufacturers will categorize the digital cameras into terms of pixel count. So you can have a 3 megapixel camera, 4, 5. Nowadays, they're 10 and 14 and higher even. But you can see that really to get a good 4:6 print, all you really need is a 3 megapixel camera. And where the benefit of having a larger pixel camera is if you want to enlarge the print to a 20:24, for an example, then if you have a 14 megapixel camera, that's certainly going to come in very handy for enlargements. Now you can get cameras that have digital zoom and optical zoom. And it's important to understand the difference between the two, because an optical zoom works just like a zoom lens on a film camera. It changes, you can see it going in and out, and it's optically, moving to be able to get closer to the image. Whereas a digital zoom basically just crops the image to a smaller size and then enlarges it. So you can see it doesn't quite give you the clarity as an optical zoom. So traditionally I don't work with a digital, only with optical, to try to get the best clarity possible. Now you'll have different file formats that you could use to save your pictures when you take them on your camera. There's JPEG, there's TIFF, there's RAW, and this just gives you a very quick understanding here that if you're shooting in RAW, you're going, like most pros do, you're going to get a much better image to work with and to be able to modify later on. JPEG traditionally has a tendency to compress the image, so it takes up less room on the hard disk or on your memory card, but you can lose some data as you're compressing and uncompressing over and over again. Well, with those simple few tips in mind, let's go out and shoot. We look forward to seeing you in the next session.